All right, let's do a little bit more practice with SOH CAH TOA, work through a few more examples. So starting here with sine of b, right? Whatever angle is inside the parentheses of your sine, cosine, your tangent, that's the angle you want to start at. So I'm going to go over here to angle b. And since this is sine, and we're going to use the SO part of SOH CAH TOA. So we have sine is equal to opposite over hypotenuse. So we need the sides that are opposite of b, which is going to be 3, and then over the hypotenuse, which is always going to be 5 in this example. So 3 over 5 is equal to sine of b. Tangent of b, we're going to go back to angle b, but this time we're going to do tangent is equal to opposite over adjacent. So opposite of b, again, is 3. And then adjacent, right, well, both 4 and 5 are adjacent, but 5 is the hypotenuse, so we're going to go with 4. So tangent of b is 3/4. Cosine of a, well, this time we're going to go to angle A, and then we're going to figure out what is adjacent to angle A, and then what's the hypotenuse. So adjacent to angle A is going to be 3, right? Because 5 is the hypotenuse, so we're going to have 3 divided by the hypotenuse, which is 5. So cosine of A is 3/5. Cosine of B, again, go to angle B, and then what is adjacent to B? Well, that's going to be 4, and then the hypotenuse is 5, so cosine of B is 4 over 5. Tangent of A, go to angle A. What is opposite of angle A? Well, that's going to be 4. And then what's adjacent to angle A? Well, that's going to be 3. So 4 over 3. Tangent is opposite over adjacent. So what if you're given something like this, where you want to find the missing side length there? You want to solve for x. And you're given another side length, and then you're given an angle measurement. Well, we're going to use some version of SOH CAH TOA. So what I usually like to do is whatever angle is given to us, right? So in this case, that's the 30-degree angle. Let's hang out around here. We're going to go there. That's our starting point. And I want to look and see what sides am I given to work with. Well, I'm given this this x over here, which is opposite to that angle, that 30-degree angle. So we have an opposite side. And then this 8 over here, right, that's directly across the right angle. So that's the hypotenuse. So we have opposite and hypotenuse. Hypotenuse. So which one of the SOH CAH TOAs involves opposite and hypotenuse? Well, it's sine. The first part is SOH. So sine, we could say sine of 30 degrees, right? The angle always goes in the parentheses. Sine of 30 degrees is equal to opposite, right? What side is opposite of 30 degrees? Well, it's x. And then we're going to divide by the hypotenuse, 8. So now this just becomes an algebra problem, and we can isolate x and then solve for it. So, right, x is being divided by 8. So I'm going to undo that division by multiplying both sides by 8. So these 8s will cancel out. I'm going to have x is equal to 8 sine 30 degrees. So this is where you will break out calculator and go ahead and plug things in. Make sure also that you're in, I don't know if it'll focus. Let's see. All right, it should be in degree mode. You should see DEG on your calculator before you start plugging stuff in. So here we're going to do 8 times sine of 30, and that's going to give us an answer of 4. So x is equal to 4. All right, similar type of problem, work with what you're given. So the angle that we are given, we're always given the 90-degree angle, but the other angle that we're given, this is where we kind of want to start or be our starting point. So relative to this angle, what sides are we given? Well, I'm definitely given a hypotenuse, right? That's that 13. And then if I'm standing at that angle right there, what is x in relation to it? Well, it's not opposite, right? Because opposite would be over here. It's not the hypotenuse because we already said 13 is that. So this just leaves us with the adjacent side to that angle. So which one of the SOHCAH TOAs includes adjacent and hypotenuse? That's going to be cosine. So we can say cosine of 27 degrees is equal to adjacent over hypotenuse. So we're going to have x over 13. What am I going to do now? Well, I want to isolate x and solve for it. So x is being divided by 13, so I'm going to undo that by multiplying both sides by 13. Those will cancel out. We're going to get x is equal to 13 cosine 27, right? Now we can plug that into the calculator. 13 times cosine 27, and we're going to get something like 11.583. We can call it 11.583. Okay, for this one, we want to solve for all angles and sides, which we can do. The first and probably the most important thing that you should know about triangles, even before getting into Pythagorean theorem and all this stuff, is that if I add the angles of a triangle, I'm going to get 180 every single time. Doesn't matter if it's a right triangle or whatever. All triangles, if you add the angles together, you're going to get 180. So I could write this out. I could say angle, that's a symbol for angle, angle A plus angle B plus angle C, all of that is going to equal 180 degrees. Well, we have two of our angles, so this should be pretty easy. We can find the missing one. So angle A is 27 plus angle B, we don't know. I'll just write the letter. Plus B, and then plus angle C, right? That's a right angle, which is 90 degrees, and all that should equal 180. Well, 27 and 90, those two together make 117. So we got B plus 117 is equal to 180. I'm going to subtract both sides by 117, and we'll get B is equal to, what's that, 63? 63 degrees. So angle B, let's fix that. Angle B is 63 degrees. Okay, so now we need to find our missing sides. And the first way we want to do this, we could do this a couple different ways, but we want to use SOHCAH TOA. So let's start with, we'll use this angle since we were given it first. We solved for B, so you could use angle B as your starting point. And as long as you did the math right, you'll get the same answer. But we'll start with angle A since that's what's given. So over here, what am I given, at least in terms of sides? Well, I'm given this 10 over here. And relative to angle A, 10 is going to be, what is that? It's not opposite, right? Because lowercase a would be opposite. C is the hypotenuse. Should always write that. Make it easy. So that means this 10 is going to be adjacent to angle A. Okay? So we know the angle. We know one of our sides. Which other side do we want to solve for? Well, we could pick either one. Let's go with, how about we go with C over here. All right, so I want to figure out which of these SOHCAH TOAs are going to involve an adjacent side, the hypotenuse, and an angle. So really we're just asking about adjacent and hypotenuse, and that's cosine. So we can go over here. We could do cosine of 27 degrees is equal to adjacent over hypotenuse, so 10 over C. So that's the setup. And now we want to solve for C. So there's a couple different ways that we could do this. Since C is in the denominator over here, I want to get it out of the denominator. So I'm going to multiply both sides by C. Okay, and that's going to cancel those two out. And what we'll have is, we'll do C times cosine of 27 is equal to 10. Okay, well, we want to solve for C, so it's being multiplied by cosine of 27. So what I'm going to do is I'm going to divide both sides by cosine of 27, So these ones will cancel out, and we'll be left with C is equal to 10 divided by cosine of 27. And just punch that into your calculator. So we'll do 10 divided by cosine 27. That's going to give us 11.22, we could call it. So side C is equal to 11.22. So now all that's left is to figure out what the length of A is, or side A is. We could use SOH CAH TOA, but we could also use Pythagorean theorem. So why don't we just do that, right? Because we found out side C, so we have that side, we just have one missing side, and we can use Pythagorean theorem for that. So we're going to go with, we'll just write it out. We'll say A squared plus B squared equals C squared. Well, A squared, that's our unknown, so I'm going to leave that as A squared, plus B squared, right? That's the other leg, so that's 10. And I can just say, hey, what's 10 squared? 10 times 10, that's going to be 100, equals C squared. So that is, it's going to be 11.22 squared. I don't know what that is off the top of my head. So I'm just going to punch that in the calculator, and we'll get A squared plus 100 is equal to 125.96. And then what we want to do is we want to get A squared by itself, because eventually we're going to solve for A. So let's start by getting A squared by itself. So we're going to subtract both sides by 100. Those will cancel. We'll have A squared is equal to 25.96. And we want to solve for A, not A squared. So what do? Well, we want to take the square root of both sides, and we will get A is equal to, and then let's do this. So square root 25.96, it's going to be a little bit more than 5. 5.095 is our answer. So we have solved for every angle and every single side here using a combination of SOH CAH TOA and Pythagorean theorem. For this last one, we want to find the entire length of what we're calling x here. And we've got 3 triangles. If we look at it, right, we got this one over here, we've got this one, and then we've got the big one that kind of connects the two. So since we're still doing SOH CAH TOA, that's what we're going to work with and see if we can't just start figuring out pieces of information. Eventually, the answer will kind of appear out of nowhere, seemingly. Since this is a right angle, and then this side is a straight line, we can say that that is also a right angle. Okay, so now for a moment, let's just talk about that left triangle. And maybe I'll redraw it. I'm going to draw it over here. So we'll call this, this is 12. That's 39 degrees, and then that's the right angle. And I think we should figure out what that leg is. I'm going to call it A. Well, always start with the angle that's given, so 39 degrees. And relative to that angle, what sides are we given, or what sides are we working with? Well, I'm working with the opposite side, so definitely opposite. And then this 12, that's the hypotenuse. So I have opposite, and hypotenuse. Which of the SOH CAH TOAs use those two? Well, that's going to be sine. So we can say that sine of 39 degrees is equal to A over 12. I want to solve for A, so what am I going to do? Well, I'm going to multiply both sides by 12. These 12s will cancel out, and I'm going to get A is equal to 12 times sine of 39. Break out the calculator. So 12 times sine of 39 is 7.55. So A is equal to 7.55. So we found the length of that, all right? Next thing we need to do is find the length of that leg. If we want to find the length of this pink leg, right, we're going to be working with this triangle over here in orange. Problem is that we are given no side lengths, but we can find at least one of the side lengths. Can't find this one with the information we're given. Can't find that one with the information we're given. So let's see if we can solve for that side length. And the way we're going to do it is we're going to go back to that original triangle that we first started with, because we're given a lot more information in that one. So I'm just going to reference that guy right there. If I wanted to solve for, let's call it B. Let's call that side B. And I want to use this angle again. Well, let's see. If I just use, again, this angle here, B, relative to that angle, that's going to be adjacent to it. So we have an adjacent side. And then I'm just going to use that hypotenuse again. Never hurts. Never hurts to use what's already given to you. So we got adjacent and hypotenuse. That means we're using cosine, CAH and SOH CAH TOA. So we'll have cosine of 39 is equal to adjacent, which is B, over 12, which is the hypotenuse. And then we want to solve for B. So what I'm going to do is multiply both sides by 12. These 12s are going to cancel out, so I'm going to be left with B is equal to 12 times cosine of 39. Plug that into calculator. 12 times cosine of 39. It's going to give us B is equal to 9.32. We'll call it. All right, so we have figured out this side length. We can call it B. And now we can figure out the length of this pink leg right there, since we know what B is. So this time we're going to look at this right triangle over here, the one on the right side, I should say. And then our starting point is going to be this angle, that 61-degree angle. Well, we want to solve for, and we can call this, let's call this side, let's call it, not D, let's call it G. All right, so we want to solve for G. We know B, and we know that this 61-degree angle is kind of our starting point. So G, right, that's opposite of the 61-degree angle. So we've got opposite. And then B is going to be adjacent to the 61-degree angle, because remember, this side is the hypotenuse. So we got opposite and adjacent. And which of SOH CAH TOA involves opposites and adjacent sides? That's going to be tangent. So we'll have tangent of 61 degrees. 61 degrees is equal to opposite, which is going to be G over B. Well, we know what B is. We just solved for it. So I'm going to say tangent of 61 is equal to G over 9.32. And we just want to solve for G. So I'm going to multiply both sides by 9.32, just like that. The 9.32s on the right side, those are going to cancel out. So we're going to be left with 9.32 times tangent of 61 is equal to G. So when I plug that into the calculator, 9.32 times tangent of 61, that's going to be 16.814, we can call it. So now, remember, the original problem is asking us, hey, solve for x. And we really need to figure out the purple and pink legs, what those lengths are. And we found it. So remember, we called this over here, this was A. So x is equal to A plus G. Well, what's A plus G? That's going to be the 16.814 plus 7.55. So x is going to equal 24.36. So we had to go through a few steps to get the answer, but it gave us a lot of good practice using SOH CAH TOA and breaking a big problem into a lot more smaller and more manageable pieces.